What's up, everyone? In this video, we're going to be continuing our study of equations of circles. So just a little bit of a recap of what we did in the prior lesson. We need two things to create or determine the equation of a circle. We need the center of that circle, which is denoted by h comma k, and we need the radius of our circle, which is denoted by the lowercase letter r. Now, to find our radius, we might be able to count it if it's a nicely drawn circle on a graph. We might be given it by the question, or we might have to use some prior knowledge, like the distance formula, to help us figure out what the radius actually is. Now, some things to keep in mind, the equation, the conic form for the equation of a circle, is what we did. We have x minus h squared plus y minus k squared equals r squared. Now, two big things to remember. The signs of your center flip in the equation. And we'll go over that quickly with two examples. But also remember that this value here on the right side of the equal sign is the value of the radius squared. So don't forget, you have to take the square root of this to figure out what your radius actually is. So bringing these ideas quickly together and refreshing them in our brain, we might have equations of circles that look like this, right? This is in conic form. And end goal for most of these questions is going to be, hey, can you find the center and the radius? So remember, these signs of our center flip in the equation. So our center is not at -2, 1. We have to flip those signs. It's at 2 comma -1. And our radius, right, this is equal to the radius squared. So we need to actually take the square root of that number, and we figure out that our radius is 3. Now, another example, again, this is another equation of a circle in conic form. And again, they're asking us to find the center and the radius, so we have to flip these signs. So our center is at 5 comma 7. And again, our radius is actually the same number, right? So we know that our radius already, we take the square root of 9, we get 3. Now, there is another form for equations of circles that we are going to learn, but let's just bring our knowledge back to equations of lines for a second. So remember, when we had equations of lines, there were two different forms. We had slope-intercept form, which was y equals mx plus b, and we had point-slope form, which was y minus y1 equals m times x minus x1. Now, we've gotten comfortable with kind of converting between these two forms, right? It's the same idea for equations of circles. So yesterday we did conic form, and today we're going to learn about a new one. So remember, conic form was this x minus h squared plus y minus k squared equals r squared. Now we're going to learn also about something called general form. So general form looks super messy. It looks like there's a lot going on, but really all it is you have all of your variables kind of expanded. So we have x squared, we have y squared, we have -4x, we have plus 2y. There's a lot going on. And we're going to learn to convert. So when given equations of circles in general form, right, which remember is this like messy looking form over here, we like to convert them into conic form so that we can easily make conclusions about the center and the radius, right? That's going to be the end goal of all of these questions is, can you find the center and can you find the radius of the circle? And we are going to do this by completing the square. All right, so we are going to go back to a slightly less complicated example, and we're just going to practice or refresh our brain on completing the square. So you can see right now that this equation that we're working with is not as complex as the equations in general form, right? We don't have two variables. There's not as much going on in this example, but that's okay because we're going to just refresh our brain on the steps of completing the square, and then we can extend that knowledge. So step 0, before we even start to do anything, we need to move our constant term alone on one side of the equation, and we need to divide any GCFs if necessary. So the constant term is going to be the term that doesn't have any variable multiplied with it. So our constant term is that 35, and we need to move it over. It needs to be alone on one side of the equation. So we have to actually subtract it on both sides, and when we do that, we get x squared plus 12x equals -35. Now, it also says to divide out any GCFs. A dead giveaway that you would have to divide a number out is if there was a number other than 1 in front of this x squared. Because in this course, we only focus on our leading term, right? Our number in front of this x squared, it has to be 1. And if it's not 1, that means you're going to be able to divide it out. So in this case, our leading coefficient is 1, we don't have to worry about that right now. So we can move on. So actually step number 1 says add one blank space in on both sides of the equation for each variable that you are completing the square for. So right now, we only have x in this case, so that means I'm going to add one blank space on the left, so x squared plus 12x plus something equals negative 35. We have to add it on the right as well, plus something, right? Now, step 2 says identify your constant of proportionality / the b term. Now, these are all fancy words, but in simpler terms, and you can add this into your table if you'd like, it's the number next to x. Meaning, I'm not looking at this x squared over here. I'm looking at the term that has x in it, and my constant of proportionality, right, or my b term, is going to be this number that is right next to x. So that means that our b value, or our constant of proportionality, is 12. Now, the next step says add 1/2 of b squared to both sides of the equation. So we're going to go back. I'm going to rewrite what I have here. We have x squared plus 12x plus blank equals negative 35 plus blank. And we're actually going to fill in these blank spots right now. So it's important here. You can see we're halving the value of b first. So we're doing 1/2 of 12. And then we're going to take that and we are going to square it. So when we do 1/2 of 12, we get 6, and that's what we're going to be squaring. Now, when we do that, we're going to get 36, and that's the number that we're filling in these blank spaces. So we have 36 on the left and 36 on the right. And again, the reason that we're adding it on both sides is so that we're not changing the equation. It's still staying balanced. We're adding the same thing on both sides, so it's not really changing. Now, the next step says use AM method to factor the trinomial. Now, on the right side, we can just simplify that. Those are just two numbers. Negative 35 plus 36, that's just going to be positive 1. But this left side, this is the trinomial that we need to use AM method for. So if you remember, AM says we need to find two numbers that add to positive 12 and that multiply to 36. So if we're using AM, we make our two sets of parentheses, right? And if you go through your options, you're going to get x plus 6 and x plus 6. Now, this isn't simplified enough, because remember, when you have the same thing multiplied by itself, you can simplify this to x plus 6 squared, right? And we still have equals 1 on the other side. Now, this is really, now there's a trick that we can use here. So a trick is to just do x plus 1/2 of b squared. Now remember, when we did that 1/2 of b, we did that over here, right? We had to find 1/2 of b squared anyway, right? So we already have half of our b value, and if you notice, that value goes in here, right? We had x plus 6 squared. Now that's going to be the case all the time. If you do x plus 1/2 of b, that's going to be the case always. But if that confuses you, if the rule is confusing to you, don't use the rule. Just use AM method. Okay, so in this case, a fully simplified version, right? We go from this equation over here, and by completing the square, this turns into x plus 6 squared equals 1. We are going to use these same steps to complete the square with two variables. So now this equation that you see here, this x squared plus y squared minus 4x plus 2y minus 4 equals 0, that is the equation of your circle in general form. Now, if this was given to you and they say, hey, find the center and the radius, you're going to be lost. We need to get it into that conic form where we have x minus h squared plus y minus k squared equals r squared. We need it in this form so that we can make those conclusions, right? So now the only difference here is that instead of completing the square with one variable, we need to complete the square with two variables, because now not only do we have x, but we have y as well that we need to complete the square for. So the steps aren't all that different. So step 0 says, move the constant term alone on one side of the equation, divide any GCS if necessary. That's not changing. The only thing that we're adding is what I've underlined in this step. It says group all x and y terms together. Now, let's make sure our constant term is this negative 4. So 1, we need to make sure that that is on one side of the equation. So we add 4, we add 4. We know that this value on the right side is going to just be 4. But now we need to regroup our terms. We have x squared plus y squared minus 4x plus 2y. So what we're going to do here is we're going to take all of our x terms and we're going to put them next to each other. So we have x squared minus 4x take the signs of the terms with it. And then let's do green. We have y squared plus 2y. So plus y squared plus 2y. Right, so all we're doing is rearranging the left side, grouping all of our x terms together, grouping all of our y terms together, and again, the same thing applies. We have to have that constant term move to the other side. Now, in this case, our step number 1 was typically to add one blank space on each side. But since we're doing completing the square for two variables, we need to add two blank spaces. So essentially what you're doing is you're going to be completing the square for your x terms, and you're going to be completing the square for your y terms. So for our x terms, we'll keep that in blue. X squared minus 4x plus something, right? Plus y squared plus 2y plus something, so we need to add something for both the x and the y, is going to be equal to, and we'll try to keep this color-coded as best as we can, is going to be equal to 4 plus, right? And then we each need to add in our blue blank and the green blank, right? Because we have to add these blanks in on both sides of the equation. Now, in this case, it says, again, now we need to identify our constant of proportionality or our b terms. But in this case, since there are two variables, there's going to be two b terms. So I like to set up a table on the side. I find my b value for x, and I find my b value for y. So our b value for x is going to be the number right next to x. So our b value for x is -4. So b equals -4. And then for our y terms, our b value is +2, right? Now we know our next step is to add 1/2 of b squared to both sides of the equation, right? But now in this case, we have two variables, which means we're going to have to add 1/2 of b squared for our x terms and 1/2 of b squared for our y terms. So for our x terms, when we do we got to do 1/2 of -4, and we're going to square that. When we do 1/2 of -4, we get -2. We're going to square that. Now remember, when we do that 1/2 of b, this number here is really important. This is the number that goes in parentheses, like when we have to do our little AM trick. When we simplify that fully, we are going to get 1/2 of b squared is going to be +4. So we're going to add 4 over here, and we're also going to add 4 over here. And then we need to figure out 1/2 of b squared for our y terms. So when we do 1/2 of 2, we got to square that. When we do 1/2 of 2, we get +1. Now remember, this number right here is important because this is what's going to go in the parentheses for our y. Now when we simplify that number fully, we're going to get just +1, right? 1 squared is just 1. And that's what we're adding to both sides over here. Now, when we fully simplify this right side, we get 4 plus 4 plus 1 is 9. And now what we would need to do is we would need to do AM method with your x terms, and you would need to do AM method with your y terms. So again, if you were doing AM, you would need to find for your x terms two numbers that add to -4 and that multiply to +4. And for your y terms, you'd have to find two numbers that add to +2 and that multiply to +1. So in this case, for x, you can do x minus 2 times x minus 2. And then for y, we would get y plus 1 and then y plus 1. And then that would simplify to x minus 2 squared plus y plus 1 squared. But let's use our trick. So our trick says that it's going to be, for our x terms, it's going to be x plus whatever 1/2 of b was. 1/2 of b, 1/2 of b is actually a negative number. It's -2. So it's going to be x minus 2 squared, right? And then we're going to have plus, and now we need to do it for our y term. So we're going to have y, and 1/2 of b in this case was this number right here. That was +1. So y plus 1 squared is going to equal 9. Now from this is the form that we're used to seeing. This is the form where we're able to figure out the center and the radius. So in this case, the center of our circle, we need to flop these signs. The center of our circle is at 2, -1. And then remember that this is the value of your radius squared. So our radius then is going to be equal to the square root of 9, which we get 3. Now, you guys should have your notes as detailed as possible so that you can refer to these steps, but with practice, it'll get a bit easier.